go. First of all, how do you spell parallelogram? Parallelogram. What did you say you spell it?
P-A-R-E-L-O.
J-E-L-L-O.
R-A-L-L-E-L-O-G-A-R.
Let us therefore define such things as parallelograms. What is a parallelogram? What was our exact definition? It was under quadrilateral. There's a special type of quadrilateral. It is a quadrilateral that has, it's a four-sided shape with, two pairs of parallel lines. Four sides, I guess. Two pairs of parallel sides. So usually what we think about when we think about parallelograms is a shape that looks like this. Was it this class that we talked about angles and stuff? Inversion? No. Didn't think so. Joseph, don't mind me. A, B, C, D. Just a couple definitions about parallelograms. That would be this. Angles that are across from each other are called opposite angles. And opposite angles are equal. What does that mean for the average sixth grader? Somebody?
What is it?
What that means is this. If this angle here is 135 degrees, guess what else you know? If angle D is 135 degrees, then also is the angle that's opposite Aaron Murray. Angle B is also 135 degrees. Righto? Wow, I can tell you are as amazed by that as I thought you would be. In addition to that, children, yes, here it is. In addition to opposite angles being equal, we have another thing called adjacent angles. Guess what adjacent angles are? No, I mean, guess what they are? And by adjacent angles share the same side. So we should probably write that down. Is this too big? Is it distracting?
No, it's fine.
So adjacent angles mean like this. These two angles are adjacent. Why? Because they share side AB. So if you look at this angle here, angle D is adjacent to angle A. What do you think we know about them? Somebody, I've got all day long to wait for somebody to answer something about them. Aaron Murray.
They equal together.
Yeah, yep. By the way, we call that, when they equal 180 degrees, we call that supplementary. When in math, talk like math people. Do we know how to spell supplementary? How about like that? Would it help? Would it look better if I did this? This might be kind of cool. I'm writing something. And by supplementary, children, that means supplementary angles add up to 180 degrees. supplementary angles add up to 180 degrees, or a straight line, if you will. So if I know that angle D is 135 degrees, can anybody do the math in your head as to what angle A would have to be? Anybody? Anybody at all? Oh boy. Chase, you seem to be confused. What do you think? Lauren, who always has that quizzical look on her face. Of course she knows. Huh? 45 degrees is correct. 45 degrees plus 135 degrees is 180 degrees. And if I know that, boys and girls and kids of all ages, how big is angle C? Joseph,
45
how do you know that?
Because these things.
Yes, look at Joseph got it. This angle and this angle are adjacent. They share this same side. So it is 45 degrees. For what other reason would it be 45 degrees? Can you tell me that? Clausing? Why else? What other? Welcome, by the way, to the world of geometry. Geometry, you have to prove things based on things that you know. And now I know that it's 45 degrees. For one reason is because it's an adjacent angle, but for another reason it is, let me point you to the way. Crossing? Let me point you to the way. Yeah, it's opposite of angle A. Opposite angles are equal. This is opposite of that, so if this is 45 degrees, that's got to be 45. This is 135 degrees, this has to be 135 degrees. What do you think? Does that not really make you math fun for one and all? Now, of course, you're wondering, what else is there to know about parallelograms?
What else do you know about parallelograms?
I'm so glad you asked. We also need to be able to figure out how to find the area of a parallelogram. Have we done areas of triangles? Anybody? What?
No.
Are you kidding?
Yes, we have. No, we haven't.
Areas of parallelograms. This, I think, is something for you to write home about if you don't live at home. Here's my parallelogram. Let's say this is 7 inches and this is 5 inches. I'll give you the formula for the area of a parallelogram. The area of a parallelogram area equals BH. Anybody know what the word letter B and the letter H stand for? You want to take a shot at it? Bonus points if you get half of one right but not the other. Yes, Olivia?
Base times height.
It is base times height. Let's write that down. Base times height. Now, a little clarification here. See if you can focus in on this. Hone all of your 6th grade mental abilities here. In math, when we use the words base and height, when you use base and height, those measurements, I'm going to put this in super big letters so you catch on to this, must, M-U-S-T, must form right angles with each other. which means they must be perpendicular. Another way of saying that is perpendicular. Perpendicular means they form straight right angles with each other. Did I spell all that right? Did I spell parallelogram right up there? So, here we go. Here's my parallelogram. Got this one written down. Here's my parallelogram. Who wants to take a stab at what the area of this parallelogram is? I have no takers out there at all. Zach Roth,
35.
35 is not right. Somebody else want to take a shot at that? Zach, did you not hear what I just said? How do you find the area of a parallelogram? Oh, what's the formula for area of a parallelogram? Would it help if I outlined it in blue? How do I find the area of a parallelogram? What is the formula, Zach?
Base times height.
Okay, and what do the base times height? What do the base and the height have to be? Zachary. Zachary.
Perpendicular.
Sure. So I need the two perpendicular lines there, which are what? Sittler, you seem as though you've got it all together. Area of that shape is? Anybody? Aaron Murray. Say it, I know you're thinking it. Go ahead. Say it. Say it, Aaron. Yes, so, hence, follow through with that statement. Say it. Shannon? I need somebody to say it. You are all thinking it, and nobody's willing to say it. What is the area of that? Grace? Ooh. Lauren? Did you say something? No. Sorry. Good try.
55 square inches.
No? Let me go back to this. The base and the height, ladies and gentlemen, have to be perpendicular with each other. So please, multiply the two perpendicular lines together. Sarah Grace?
49.
No, but that's a reasonable guess. Do I have anybody out there? Is it like some sort of a puzzle? Zachary?
25 or 49.
Did you say 25 and 49?
Or
No, you can't have two different measurements, and neither one of those is right, I don't believe. Anybody? This awkward moment is brought to you via Math Learning. Yes? No. Oh, Diedrich thought that was funny. What do you have?
69.
No. Joseph? Throw any number out there. Go ahead, say it. Any number at all. Joseph. Come on, give me a number.
400.
Nope. Nobody's going wrong. Ladies and gentlemen of the jury, you can't find the area of that because there are no two perpendicular lines given to you. I only tell you that for the simple reason that tomorrow in the book they will give you a problem like this, but the book will actually give you the perpendicular line like this, and they'll do a little square angle here, and they'll say this is 4. I only say that because tomorrow, I guarantee you, half of you will tell me that the area of this is 35 and not use the two perpendicular lines, even though I said it 1,000 times, and everybody couldn't figure it out when I did say it. Now that I told you it is, you should be able to figure out that the area of that is actually, what two lines form the right angle, Olivia?
7.
And which is what? Area equals base times height, area equals 7 times 4, and it doesn't matter which one you call that, area equals 28, whatever it is, inches squared. So get that in your head because it's going to come up with triangles too. Okay, you have to, if anytime you see base and height, they have to form, did I do something wrong? Right angles. I just made it up, by the way. You can't figure it out based on the numbers. The book has to tell you it. Is that what you were gonna ask? How did I know to put a 4 there? I just put it there. You could do it, if, by the way, the Pythagorean theorem is up there, you probably could figure it out, but we're not gonna do that. So you got that? So here we go. Let's see how many people caught on to that. Here is my other parallelogram. Let's do a parallelogram that looks like this. Let's say this is 6 and this is, let's go 5. The area of that is, Chase? Chase, I can't make an easier shape than that. You should really do the math right here. The area of this parallelogram, Chase. This one right here, I got on the board.
24.
Huh? I don't think so. Olivia,
There's no area because there's no area.
thank you. You don't know. You have no idea. You can't figure it out unless you are given the perpendicular line. I'm going to do it one more time and see. Now it just happens that in this case, Chase, look. This line was given as a 3. How about that? What is the area of that? Chase?
18.
There we go. 18. Whatever it is. Let's do centimeters. Centimeters squared. All right, I'm going to do a really big one and see if we caught on to that. Let's say this is 100 and this is 80. Let's do millimeters just for consistency's sake. The area of my parallel, by the way, if this comes up on your homework, ladies and gentlemen, you will sketch the problem out. You will put the dimensions down, yes. You will write the formula for area of a parallelogram, which is base times height. And then you shall calculate such base times height. And Cassandra Malis, the area of this is? Thank you very much. Not until somewhere, somehow, somebody, and maybe it goes like this. Sometimes they make it look like this and they do a dash line. But you will know the 2 lines because there will be a square corner that tells you that those 2 things are perpendicular. And maybe this is what, 70? So the area of that is what? 70 times 100? Anybody in the head? 70 times 100 is 7,000 millimeters. One more, I'm just going to make this one as hard as humanly possible. Area of that parallelogram. Caleb Fisher.
120 square centimeters, right? No, yes. 120. Oh, you can't find it because there's.
Oh boy, now we've got a whole bunch of different answers here.
Yeah, 120 squared.
Who agrees with that? Almost somebody, Caleb. We were close. Who else is up there? Sittler, you're saying, what's that? This is killing me. Gianna.
Can't do it.
Wait, now let me write this down for you, kids. Area equals base times height. And the base and the height have to be what? The other 2 lines that are perpendicular there.
Yes.
See the little square corner? Area equals 30 times 40. Caleb, you had to use your digit multiplication wrong.
It's 12.
4 times 3 is 12, and then you tack 2 zeros on it. Should have been 1,200. Alright. This is a rectangle, people. A rectangle is a special kind of parallelogram, but it already has all the right angles. So that's why in rectangles you can just do length times width, because all lines are perpendicular to each other. This is the key. Look for this little square doohickey thing there, because that'll tell you that it is. All right, here we go. One more time. Let's see if I can really do it this time. $30, $40, $20, which would not make any sense, but it is what it is. Oh, wait a minute. Maybe I'm missing something here. What is the area of said parallelogram? Area of this parallelogram. Again, you would sketch that on your paper and you write out area equals base times height. Autumn?
You can't do it.
I guess the question you would ask yourself, is there no two perpendicular lines? Is there nothing in there that has a square corner? If there is, then maybe we can do it. The two lines that form the right angle are your base and your height. Olivia?
The area is 800.
The area would be 800. Why? Because this little square corner, base times height, or height times base, it doesn't really matter. 20 times 40, which is 800. Whatever we're talking about, centimeters squared. Hold on a second.